we're no longer going to be using a compass in order to prove things are congruent or tell things are parallel or perpendicular. Now that we're going to be moving kind of past like looking at a diagram and like just marking it to show our intent, we're going to replace that with some calculations. And so let's talk about how we can use slope in order to tell perpendicular and parallelism. First, let's just talk about slope as a thing. And so this is a reminder probably from previous grades, but when you're talking about a slope, we're just talking about the measurement of line steepness, which just really tells you a lot about the line itself. We're going to be on a grid, we're going to be on a graph, and that's where we're going to be doing our work for the time being. And so when we talk about slope, we have to think about rate of change. Of course, you know that slopes that are positive go up, slopes that are negative go down. But the thing that you may need a reminder on is that slope is always a ratio. That ratio in particular is a change in y over a change in x. Okay? And so usually that's denoted like this. So we have a change in y over a change in x. This triangle symbol in this context doesn't mean a triangle, it means change in. So it might be worth it to make a little note here. That triangle right there means change in. Okay? So sometimes you see slope as like rise over run. Rise is like up and down. In other words, change in the y direction. Run is left and right. In other words, change in the x direction. And so now the question becomes, well, how do I find the slope in different contexts? Well, graph is probably the one that you're most familiar with, the one that you're most comfortable with, because you may spend a lot of time in middle school making slope triangles. And so if I want to know the slope of a line, of course I'm just going to pick 2 points on that line. I've kind of selected 2 for you, but the logic here is you got to pick points that are nice, a nice crossing point. And so that you wouldn't want to pick this point right here because it's just not possible to find a nice coordinate for that unless it's already given. Now, in order to find the slope here, again, keep in mind that we're just dealing with change in y over change in x. In other words, rise over run. And so we just have to determine, going from the first green point to the second green point, how much did you drop and how much did you go over? And you should think of this as a direction going left to right, okay, dropping and then moving over. And so from the green to the first green point to the second green point, excuse me, the drop here is going to be 2, but we do have to be careful because we should mark it as a -2 because we're dropping. At the same time, we're moving over to the right, 1, 2, 3, 4. And so we're going to have a +4 as far as our change in x goes, or our run. And so overall, if we're trying to calculate this rise over run as a ratio, in other words, as a fraction, we're going to have -2 over 4. Now this can be reduced because as a fraction they're both even in the top and the bottom. And so we can reduce both by half, leaving us with simply half. And so the slope, or change in y over change in x, is going to be 1/2. Okay? So that's for a graph. Now, if we don't have a graph, we're just given some points, we can still do the same kind of work. We have to acknowledge that the coordinates, of course, are going to be in x, y order. And so if we want to calculate the slope, which is just, again, change in y over change in x, we can simply track that by looking at where the x and y started and where it ended. And so if your y started at -4 and ended up at +1, that's going to be a total count of +5. So -4 to 1 is a +5 increase. So the change in y would be +5. At the same time, we can look at our x's. We go from 3, and then we end up at a 6. And so 3 to 6 at the same exact time is going to be a +3 change. And so overall, if we're looking at our slope, it's just going to be +5 over +3, or we can simply reduce that to 5/3. Okay, so again, no big fuss here. In the same way that we can use a line to track our movement, we can simply look at numbers and do that too. If we were to look at this, say, on a graph, quite roughly, 3, -4 would be like over 3, down 4, be about right here. And then 6, 1 would be 3, 4, 5, 6, and then up 1. And so we can see the slope we got roughly fits like the graph that we could get from the points, up 5 over 3. In other words, up 5 here, and then over 3 there. And so you don't always need a graph to do this, you can just use points. The last situation is if we just have an equation. Now you do want to call from Algebra 1, this equation falls in the form y equals mx plus b. All linear equations do eventually, where the m defines explicitly your slope, and then the b value defines your y-intercept. And actually, we should include the sign there, so y-intercept. And so we can just simply read the equation above, since it is an mx plus b form. The m occurs in front of the x as a coefficient, therefore that's our slope. And although it's not important for this particular exercise, we can also see that that's the y-intercept. Okay, and so you have three situations. If you're going to find the slope from a graph, you can make a set of triangles and track the rise over run. If you just have points, you can observe that the slope formula, is change in y over change in x, and you can simply look at those changes between the 2 points, as long as you remember the coordinates are always listed x comma y. Or if you have an equation that's in the y equals mx plus b form, you can simply read it. The slope is a number that occurs in front of the x when the equation is in this form, and so you can just read it directly from that. All right. So let's pause here. Go ahead and grab the practice from me, and just practice getting really good at finding slopes, because it's going to be really important to telling if lines are parallel or perpendicular, because the slopes are how we're going to do that. All right. Thanks.